Have you ever really stopped to think about what happens when you send Bitcoin? We use phrases like sending coins, right? But what does that actually mean? Well, let's dive in, because what's happening under the hood is way, way more interesting than just a digital file zipping from one person to another.
First things first, we've got to reset how we think about money. With physical cash, it's simple. I want to pay you, I hand you a dollar bill. It's a bearer token. Whoever's holding it owns it. Simple. Bitcoin, though, it's more like transferring ownership of a piece of land. You can't just pick up the land and hand it to someone, can you? No way. Instead, you go to a shared record, a ledger, and you update it to show the new owner. Bitcoin is exactly that. It's not a thing you hold. It's an entry on a giant shared ledger.
And that right there is the million-dollar question, isn't it? If there's no bank, no government office, no central authority keeping the books, how in the world do you get thousands of computers all over the planet to agree to update their copy of the record in the exact same way at the exact same time? The key, the secret to it all, is the transaction itself.
See, a Bitcoin transaction isn't a thing that moves from wallet A to wallet B. You got to think of it as a set of instructions. It's a carefully written message that you shout out to the entire network, telling every computer what to do.
Now, look at that word on the slide. Convince. I love that. A transaction isn't just a request. It's a piece of data that carries its own mathematical proof. It proves you have the right to spend the Bitcoins you say you have, and it gives crystal clear instructions about who gets to control them next. The network doesn't trust you, not for a second. It just verifies your proof.
Okay, enough with the theory. Let's get our hands dirty. We're going to look at the raw data of an actual real-life transaction. This is the code, the language that the computers on the network are actually speaking to each other. So, brace yourself.
Yeah, I know. It looks like total gibberish, right? Like someone just mashed their face on the keyboard. But I promise you that long string of letters and numbers is anything but random. It is a perfectly organized, highly structured piece of information. And together, we're going to decode it.
So here's the secret. All that data, it has a blueprint. Every single transaction follows the exact same pattern. And once you have the map, you can read it just like a computer does. So let's pull out that map.
And here it is. This is our blueprint, our key to understanding that code. You can see it's broken down into these neat little sections. There's a version number, a counter for how many sources of money are being used, the inputs themselves, another counter for where the money's going, the outputs, and this thing called a lock time. But let's focus on the two most important parts here, the inputs and the outputs. First up, inputs. This is the from part of our transaction. But it doesn't just say, from Bob's account. No, it literally points back in time to a specific previous transaction where Bob first received those Bitcoins. It's kind of like citing your sources in a research paper. The input is basically shouting, hey network, I have the right to spend the money that was sent to this address in that specific transaction from the past.
And you guessed it, if inputs are the from, then outputs are the to. This part of the transaction creates new spendable chunks of Bitcoin. In the lingo, we call them unspent transaction outputs, or UTXOs. These new UTXOs are now digitally locked to the recipient's address, and only they, with their private key, can create a new transaction to spend them in the future. That's how control gets passed along.
So you might be wondering, okay, I get it, but why all this trouble?
Why not just have a simple from and to like a normal bank transfer?
Well, it turns out this very specific, very deliberate structure of inputs and outputs is the secret sauce. It's what gives Bitcoin all of its amazing properties.
Because every transaction has to explicitly point to the exact funds it's spending, the whole system is just amazingly reliable. There's no room for confusion. This structure is also really flexible, or expressive. It lets you do complex things like sending money to 100 people all in one go. But most importantly, this is the whole magic trick that enables security without a bank. You don't need a central party to check balances because the proof is baked right into the data of every single transaction.
Now that structure we just went through, that's the native language of the Bitcoin network. But what if you need to do something a bit more complex, especially when you need the absolute highest level of security? Well, for that, there's another format that builds right on top of this foundation.
It's called a PSBT, which stands for Partially Signed Bitcoin Transaction.
Here's a perfect example. Imagine you build a transaction on your laptop, which is connected to the internet, but you want to sign it using your super secure hardware wallet that's always offline. A PSBT is the special format that lets those two devices work together. The laptop prepares the transaction, and the hardware wallet can safely add its signature without ever exposing your private keys to the internet. It's a massive upgrade for security.
So let's boil this all down. What are the key things to remember? First, Bitcoin is a ledger, not a folder full of digital coins. Second, a transaction isn't a file you're sending. It's a structured instruction that you broadcast to the whole world to update that ledger. And finally, that specific input and output structure, that's the whole engine that makes reliable, decentralized value transfer possible. And that really leaves us with one last, pretty mind-bending question. We've just seen that what we call money can be represented as just a secure, programmable instruction on a shared database. So if we can do that, if we can reinvent money this way, what else can we program?